Warsaw.js.
Okay, hi Warsaw.js. My name is Anton. I work as senior front-end engineer at Sumo Logic. I will tell you a story, approach which we use. Maybe you will find something interesting. I will tell you about our mistakes we did and what we learned from this. I believe that people learn more from mistakes than from success stories. So, working on interactivity performance. First of all, what is this and what the place among other things in web performance? Basically, according to MDN, I trust MDN, we can split it into 5 areas which it covers. First, reduce an overall load time. A set of techniques which you may apply to optimize loading, decrease your bundle size, make your site or web application load in faster, and everything goes into this area. Second one, making site usable as soon as possible. When we can have actually loaded site or application quite fast, but it doesn't mean that it's actually interactable. So this is a different story. And we need to ensure that as soon as loaded, it's also interactable. And that covers this area. The third, smoothness and interactivity. We will talk about it much more today. But idea is that when we have loaded application, it's interactable. Our interaction should be fast enough. Our application shouldn't be responsive. We shouldn't have situation when you, I don't know, try to create an account, click on this, everything frozen, nothing happens. And after 5 seconds, oh, account created. Great, but it's not really good performance. So fourth area in web performance is perceived performance. Sometimes we have operation which just simply slow, and we cannot do anything about this. Just think about, I don't know, you need to process 1 terabyte of data. You cannot make it fast. It's just too big. At least in nowadays, maybe in 20 years when we would have quantum computers, it would be very fast, but not today. And what we can do is actually improve perceived performance. We can use optimistic UI, simply start an action and just leave it in background. And for user, it would feel that it's fast. And basically, that's one approach, or you can show nice spinner with cats and balloons or whatever you like. And yes, there are a lot of techniques which you can do and apply. And 5 area in web performance is performance measurement, because we cannot achieve any great result if we not measure this. We maybe just, I don't know, try to improve, and we never get somewhere because we don't know what we're achieving, where we try to get, what is our result. For this, we need to measure. That's, I believe, cross area for the first previous. So, before we continue, let's remind, I just want to remind you, premature optimization is the root of all evil, almost most of it in programming. Donald Knuth. That's a very old quote, I believe, and it's quite important to remember this when you're working on performance or web performance in particular. However, small remarks, that's my personal opinion. It's not Sumo Logic opinion, just present myself here. It doesn't mean that producing an efficient solution is the right way. Because quite often we may be faced with a single choice, how we implement our feature. One is cost a little bit more, takes more time, but it's more efficient. And the second one, we can deliver faster, but performance would be worse. And in general, the better choose the first pass. You need to take care about efficiently, you just shouldn't go crazy about it. So you need to find this balance. It's very hard actually to achieve, easy to say. So when we should start working on our optimization, then if that's, we need to find the balance. So first of all, the pass begin. What is this? First of all, you need to get some confirmation that you have performance issue. You can get the client feedback. It's not nice. Usually it's your client calling you in the night or in whatever time and saying your web application doesn't work. It's very slow, laggy, and a lot of other interesting words. And it's not very pleasant. And if it's in the night, it create extra stress. There is other way to get the feedback. It's internal testing. For example, your quality assurance or quality engineers may do testing and notice, hey, this feature is slow and we can rise. So that's another way of doing this. For example, at Sumo Logic, we follow in dog fooding. It means that we are using our product and we actually have more feedback from our developers. They contribute to us and we know upfront what's going on. Is it bad? Is it good? This really, really helps. I'm not sure that it can work for everyone because some people may be working on, I don't know, medical software and, I don't know, specialized on heart issues, and not everyone have heart issues, fortunately, so they cannot test this on their own, and hopefully they wouldn't. So yeah, idea is we need a human confirmation. However, if we think about this, it's a very reactive approach, right? We just keep it go till someone came to us and say, hey, it's slow. The alternative is to do monitoring via APM solution. There are plenty of this. Again, we at Sumo Logic providing tracing for the front end. Basically, you can get information that, for example, some click operation is slow on your web application or site. There are plenty of other solutions. Just want to say you that it's alternative to getting confirmation from people. You can get insight from monitoring tools, and you should use them. This is very helpful. So, okay, Houston, we have a problem. We get out of memory, for example. Everything dead. What we should do? First of all, before starting to fix it, the first question we should ask ourselves, what is exactly slow? Is it, I don't know, when you receive feedback, up is slow. It doesn't tell us anything, right? What we can optimize? We don't know. We don't know on what look. So we need to understand first what exactly is slow, what the area is broken, what the component is slow or unperformant or unresponsive. And the next question is it slow for everyone? Maybe it's not. Maybe just some people from, I don't know, let's say Spain, and we have third-party plugin which for Spain load extra code and it's slow for them, but the rest of the world doesn't have this problem. It's important in the future for us to understand how to address this issue. And of course, we need to ask what the browser or operation system user has, because it drastically can impact performance and how application behave. Different browser has different optimization internally. Next question, is there any specific condition when performance issue occur? For example, you have, I don't know, situation you try to show on a UI 1 million of rows in the table. And the business requirement is to show everything. And 1 million of rows in the case of 0.001% of all users. So the question, should we work on this or not? Is it really the case we want to somehow handle? And one small question which we should ask ourselves, maybe we pushed something recently, or maybe there's a new feature, change, whatever, which actually led to degradation performance. So, before we kick off, relating to those questions, check if this issue needs to be fixed. Again, maybe it's just not the case. You have one user who has 1 million rows of data which you want to show in UI, and maybe you shouldn't waste your time on fixing this. Or maybe you have a functionality, close your account, which not performing well. But on other case, ask yourself, do you want to have close account performant well? Do you want people live in your system or not? Maybe it's not a bad idea to have it unperformant. Of course, I'm joking here, but the reason is why here is you need to actually try to understand if it's really need to be fixed. Not all performance issues need to be fixed. So, yeah, maybe it's not even, shouldn't be supported. Or maybe we have a feature which is underperform or has some performance degradation, but it's on deprecation plan, we were gonna remove it. So please ignore it, remove it, forget it, live happy life. Don't waste your time on optimizing this. So if all your answer on those questions are no, you have a real issue, then we come to measurement. As I mentioned at the very beginning, you cannot fix anything if you're not measuring anything. At Sumo Logic, we basically rely on two kind of measurement. Real user monitoring, basically it's some script, measurement scripts which we execute on real browser and just track how performant this or other flow. Again, we use our solution for APM general, but sometimes they're very complex flow. You cannot just, measure click on a button and how much JavaScript or CSS rendering or whatever takes, because it's way more complex. You do some API call, you get response, maybe you do one more API call, and each of these lead to some changes in UI. You actually want to capture all this flow. How bad or how good is this? And we have this in real user monitoring, and we also use in synthetic monitoring. We're using this when we identify the issue, we know there is a problem, we can actually build a test script which just measure this issue or the flow, and then we just add it to our automation test. And this helps us to prevent degradation in the future. This also helps us to understand how good or how bad we perform in those known scenarios. So it's basically become part of normal automation. And each of these has own challenges. I will talk more about this. Room challenges. As I mentioned, we use this for complex scenarios, and we discovered that in complex scenarios there may be more even complex problem. Example, you have click on a button, it starts loading data, but there are several requests, and it takes time, user get tired, and start new action. And there are more JavaScript gonna be executed in the same time, and you would get metric which just skewed and does not present the reality, how this operation works, but you just got the result which was slowed down by other user interaction. And unfortunately that happens. We try to somehow prevent this known problems. However, not everything can be captured, and 95 percentile is your friend, which help to throw away data which, let's say, not gonna happen in reality. Another case, user may change the browser tab. And, well, that's very simple scenario. Who did this? Like, site, slow, it's not getting new result, you try to get data, and you, for example, switch your tab to CNBC or CNN or Bloomberg or whatever. Please raise the hand, who did this? I do this all the time. Yes, thank you. However, when you do this, browser do a little bit different thing. It says, okay, this tab is not priority, so let's decrease the priority, and it will affect your set timeouts, it will affect your request animation frames, and if you use it and if you rely on this, you get extremely skewed data. And this is again a problem. However, this can be captured via JavaScript API, and we just basically detect changing the tab and then throw away this measurement because we know that it's gonna be bad. And user may have plugins. I believe everyone loves plugins. I don't know, I have so many issues just about logic, business logic about the plugins which they created. But with performance, it's maybe even worse, because they may inject some JavaScript which is gonna be executed in the moment when you're not expecting, but plugin expected. And you have a slow system. And again, remember our question, we need to understand who has the issue in what condition. If it's plugin, well, probably we cannot fix all plugins out there because there's so many people building them, but we need to understand what we are working. So, synthetic monitoring. I will tell you a story. As I, on the very, very beginning said, I will share our mistakes. Hopefully you will learn. So how we try to implement those synthetic monitorings? We use Protractor for our end-to-end tests. Disclaimer, we started before Protractor get to deprecation plan. It was way before this. But the idea is that it actually gives a nice scenario. We have as a user our Protractor script, which sends an interaction to our browser driver, which executes some action in the browser. And we can do measurement like real user. At least that was our plan, right? That's a known Selenium architecture which is behind Protractor. And everything was great. Like, yeah, we have some communication between Selenium client, browser driver, and browser, but it's not so bad, right? However, when we started to run this on Jenkins, we actually discovered that we have Selenium Grid, about which we fortunately forget. And it's completely different story. We have one machine which sends requests to another machine, which is Selenium Grid. And this one gonna send to the node, and inside node it will receive browser driver and then go to the browser. And our estimate showed that on our setup, we had a 1 second mistake for very simple operation, which on synthetic monitoring measurements is very, very big. And we try to achieve some measurements on level 100 milliseconds. And guess what? With such scenario, you never get such values. So lessons learned, please, if you try to do something like this, test on the real environment where you're going to execute those tests. Because you may not be surprised. And yeah, just test and ensure that it works as you think, because it may be not. So, okay, now we have measurement, we know what we are doing, we know what we are testing, how we can address the issue. The most common is profiling, right? What we can do about this? Basically, there are several types of profiling, two very popular known approach, top-down. What it means, when we try to profile some operation, we get this flame chart. And example, you have a React application on operation, there are like a lot of React components logic invoked, and you get flame like here, a lot of nested calls, one smaller than another, and it's usually very, very long. So if you have something like this, just use top-down approach, go from the top to the down and try to find what you can optimize, because from bottom to down, it can be problematic in such scenarios. However, if you have something like this, where in the bottom you can see particular big calls, you can start using bottom-up approach, which very work well in such scenario. And for us, it help a lot as well. We use both. And I like outline something. Again, that's my personal one. I called it side down. Why I talk about this? JavaScript. It's asynchronous, right? And quite often we have complex operation which may require some set timeout or something, or request animation frame or whatever. And actually, it's not look like this. We may have 3 small tasks in our profile, like you see here, 24 milliseconds. It's not big, right? That's a very small one. But as it is part of one complex flow, it actually total takes 600 milliseconds. Your first look on this will tell you, like top down, bottom up, you usually look on the one single task. Well, it's good, it works well. But just a reminder, it's an asynchronous environment. You need to take a look at all what you have as well. I just called it side down. Please don't call it like this. That just I wanted to outline somehow. So after we did profiling, what we may find, I will share what the common issues we found in our product. I believe we are not the lonely here. A lot of people finding the same issues. Relayout repaint. I don't know, so many people talk about it, so many articles written about this. There are several sources of those relayout repaint issues. Basically, when browser need to do extra rendering or a flow, most common case, you change some CSS class and then you try to get offset height or something like this and force relayout, repaint. However, maybe in general problems like we had SVG with 1000 elements, and however we just, yes, nothing fancy. We just add fill opacity for all elements except one, so it basically gives you a fade effect. Nice. But when you do this in SVG on 1000 elements, it's gonna be slow and it's gonna be laggy. And that's nothing you can optimize with JavaScript. So if you have something like this, there are popular approach which used in different libraries, basically called two-layer architecture. I believe you may have more layers in reality. Idea is, okay, we know that our DOM manipulation is slow. We want to change the appearance. So what we do, we create an extra layer. Very, very simple. If we want to fade out, so we basically need a rectangle, right, which has the color, which use an RGBA with background color of our SVG and some opacity. And we get a fade effect for everything, and it's extremely fast. We just need to draw again the element which shouldn't be faded. This works well. This is used in a lot of chart libraries when you have a lot of elements rendered as well, and you want to, for example, tooltip be shown, or I don't know, some fancy hover effect. Usually they just have separate canvas, or in SVG separate layer. We just show something hovered. They not changing original. That it gives better performance. So next thing with which we faced, I believe all JavaScript developers love functional programming, or at least at some part. Everyone use map, reduce, and it's nice. But what if we iterate in, let's say, at least 10 megabyte objects in a browser? Maybe 1 million records, and we have some functional programming approach. We allocate a lot of memory, temporal memory, but still, it actually gets worse on the performance, and functional programming on hot loops should be avoided at all cost. And imperative programming is your old, not fancy, but really helpful friend, which can solve this problem. There are also like known problem with this memory allocation. Almost all JavaScript garbage collector use, and not only JavaScript, using one heuristic is new object die soon, and all object lives for a very long time. And basically they split garbage collector cycle to major and minor, something like this. And with such functional programming, you allocate a lot of object, and you have hot loop. It takes time. Your memory pressure getting higher. And what browser, or better to say JavaScript engine, would do? Of course, it start to remove those objects because you have them too much. And well, they knew they will die faster. It's more optimized. But still, if you have 10 minor garbage collector cycle in one hot loop, it may decrease performance drastically. And we had such issues, and we had a lot of actually such issues. Of course, not optimized algorithm. Everyone knows complexity, I believe. That's everyone can face. And that's something you can find with profiling, the most common situation. And just, I cannot give any common approach because it's very specific. Like, not every algorithm can be optimized from ON in square to ON, unfortunately. So yeah, that's something you need to take care of in your low performance code if you have one. Performance operation which is not needed now, the keyword now. Quite often we have something like, again, it may be React, it can be Angular. We build a lot of components, nested structure, and instead of, for example, use an if, which will prevent rendering subtree, we may just add display none to some div. Great, it wouldn't be rendered in the browser. However, our React components or Angular components of Vue.js, whatever you're using, it's still gonna be rendered, and it will take time. And again, if you have more like some arrays which lead to complex component structure. That may be a big problem. That's something you need to avoid if you can. If you're not needed something right now, we will talk about this in next slides, what approaches can be applied. And of course, no caching for computative intensive flow. Basically, that's very popular issue. Caching is everything when you try to deal with performance. So, optimizing not needed operation. Avoid doing any rendering for things that not visible now. As I said, please, better to not render whole components instead of just visually hide, because it take time. Or maybe you have some component which need to appear. I need to wrap up. Which you don't need now after click operation, so just don't render this. And here the thing which we can use is lazy rendering. That's popular when you have scrollable area, I don't know, 200 heavy panels, you just show what you have. However, this leads to scroll degradation, which again, we talked about interactivity performance. It creates, again, problem when you scroll and it's become laggy. So the question to everyone here, does anyone know what we can do to fix this scroll degradation? Does anyone know? Suham? Pagination. Well, that can be applied. Price for this young guy. Who was this? Oh? Anya will give you a prize. Yeah, but there is also alternative technique can be applied, that one of these, and alternative is multi-stage rendering. What is this, multi-stage rendering? Basically, we say, okay, we render visible part, but we're not rendering right now the rest. So we request idle callback when the browser would have time, and we start rendering the rest part. We actually can split it in multiple stages, not just two. That's why it's called multi-stage. And basically, we rendering when we can the rest of UI, because user get the screen, user see what user wanted to get, and you in the background renders the rest, not freezing anything. But again, it cannot be applied everywhere. It has its limitation. So yeah, also wanted to talk a little bit about cache issues. The most common solution is just to use memorize from Lodash or whatever. However, the problem with memorize is that if you have web application which lives alone, for example, you create a trading platform. How trading platform function? People open trading platform at, okay, probably here it would be 9 AM when the exchange opening and closing at 17:30, and they during this time changing different trading views or whatever, but your application need to leave all this time and it should function. It's not just trading platform, I'll just give it as example. And if you have such memorize and change your view all the time and it get memorized, and memory pressure getting high, you actually have a memory leak due to this memorize. That's a big problem if you have a long-living web application. The safer way is to use LRU. How LRU works? LRU basically remember recently used calls, and you just limit. You say not to memorize everything, but memorize, let's say 100 calls. That's fine. And the rest we can invoke again. That would work well. However, if you were very attentive, there is one problem with LRU cache and garbage collector. Who knows what the problem is? Again, anyone? What was the heuristic for garbage collectors? And why LRU breaks this? It breaks it. Okay, no one. As I said, new object dies soon. With LRU, actually, you change this heuristic, because newly created object not gonna die soon. It gonna stick there, and it will lead there in bigger garbage collection cycles. and it actually may slow down your system. Again, it all depends. Please check what you have. It all really depends on your case and what you have. And yeah, that's it. Hopefully you enjoyed, and maybe you have some questions.